Hi, math friends. We're going to check out our ratio study guide today. So this first one here asks about an additive or multiplicative relationship. So a couple ways to do this. We can check out our chart here. We can see if things scale up properly. We could also check out this. If I go from 1 to 5 with multiplying or adding, right? So if I try to add plus 4, 2 plus 4, well, that's 6, so that doesn't work. So let's try multiplying. Times 5, times 5, times 5. Times 5 always works here. So this is multiplicative. I could also look at the scaling, right? 1 times 2. If I do times 2 going this way, this is also going to help me see that. So either way I did it, that works, right? Remember as you're working on this to pause and then check your work and then see those ones that were a little bit tricky for you, get a little hint and then pause it again and then see what you can do from there. All right. So here there are 23 NES games and 13 Sega games in the classroom storage closet. Write the ratio of NES to Sega games in the storage closet. So remember the order matters here. I want NES first and Sega second. So I could write 23 to 13, or we could write 23 over 13, or we could write 23 with a colon 23 to 13 like this. Any of these is okay. Typically, we want the fraction, but any are okay. Write the ratio of Sega to NES games. Now we're going to reverse the order. So I could do 13 to 23, 13 over 23, or 13 colon 23, meaning 13 to 23. Are the ratios you wrote in A and B part to part or part to whole? Well, we only dealt with the types of games, so these are part to part. Now, this is kind of a long test, a long study guide that you're going to be doing, so we don't have to write a whole explanation for this one. Part D, write the ratio of NES games in the closet to the total number of games. So I want my total games, right? So add them together. We get 36. So NES 23 to 36. I could write it as a fraction. I could write it as a ratio with the colon. Part E, write the ratio of Sega games in the closet to the total number of games. So Sega games, I got 13. So 13 to 36. 13 out of 36. Or 13 to 36 with a colon. Are the ratios that we run in the last two parts part to part or part to whole? Well, we dealt with a total, so they are part to whole. Which is greater, the ratio of NES to total games or the ratio of Sega games to total games? So we're going to say this one. And it says explain. So we could say the ratio of NES to total games is greater than Sega to total games. And we could say simply because we have more NES games. Because we have more NES games. We're going to look at some percents now too. Write a fraction and a percent to represent the shaded part of each grid. Each hundredth grid shown represents a whole. So if we count these, there are 10 and there are 10. So 10 by 10, it's 100. So right away, my fraction is out of 100. Now, how many are shaded in here? I have 2 rows, so 20. And then I have 7 more, so I've got 27. And as a percent, it's going to be 27%. This one, same idea. I've got 40 and then 3. So I've got 43 out of 100. And as a percent, that's 43%. All right, so when we get to these word problems, they're a little tricky. We got to think about what's going on. The shaded portion in each glass represents an amount of grape drink. Martin's glass of grape drink has a stronger tasting grape flavor than Tia's glass of grape drink. So they've made two drinks. His has a stronger flavor to it, right? Hers is more like watery. If we add 3 ounces of water, or if 3 ounces of water is added to Martin's glass and Tia's glass, which glass will contain the grape drink with the stronger grape flavor? So what are we adding? We're adding water to his glass and her glass. We're going to add the same amount to both. We're going to add 3 ounces of water to both. All right. So if I add the same thing, it only makes sense that his is still stronger. It's going to get weaker, but hers is also going to get weaker. So Martin's glass has to still have the stronger flavor. 4 out of every 10 people prefer Pepsi over Coke. Okay, so 4 out of 10 prefer Pepsi over Coke. Remember that the order matters. I'm going to put Pepsi in this out of 10. This is a total. So if there are 100 people in a room, how many of them prefer Pepsi? So if I have 100 total, how many are Pepsi? So let's scale up. 10 to 100 times 10. 4 to our unknown times 10. So I would get 40 prefer Pepsi. How did you determine the number of people who prefer Pepsi out of 100 total people? Well, you can say I scaled up by multiplying my ratio by 10 over 10. So we're saying this because we multiplied each part of that ratio by 10. By 10 over 10. All right, now we're going to do some scaling here. Scale up or down to determine the unknown quantity. 500 miles over 10 hours. So to get to 1, I'm going to be dividing by 10. 500 divided by 10. Right? I take a 0 off, I get 50. So 50 miles. Gotta show my work here. There we go. 450 student farts to 50 teacher farts, and then we're going to scale down. So divide by 50 to get from 50 to 1. So 450 divided by 50. How many times does 50 go into 45? It doesn't. Well, how many times does 50 go into 450? 9. So when I divide by 50, I get 9. So I have 9 student farts. All right, here's some more scaling. This time I got to scale up 1 to 8. So I'm going to do times 8. Times 8. I got to do some work here. 4 7/10 times 8. 8 times 7, 56. 8 times 4, 32. Add 5, 37. Move my decimal 1 space over at the end. So I have 37 6/10 widgets. And check out this one. 150 miles for 30 kilowatt hours to 50 miles over question mark. So this is scaling down. Divide by 3. I think of the numbers 15 and 5. I can take the zeros off to think that way. So I'm going to do the same thing here. Divide 3. 30 divided by 3, I get 10. So 10 kilowatt hours. Number 8, Rob is using a double number line to determine the amount of flour he will use to make a batch of muffins. If he wants to make a batch of 72 muffins, how much flour will he need? Well, we're going to keep scaling up here. This is just like a ratio table. So if I think of it like this, that might help. Because we've done a lot of ratio tables, and this we saw is kind of like that. So if I multiply both by 2, I get 24. If I multiply by 3, I get 36. So I can keep scaling up by thinking of multiplying by 2, multiply by 3, or I can keep adding 12 because it's my multiple. 60. At the end, I get to 72. And this is the big deal here with this one. Now, 1 3/4, I have to add another 1 3/4, right? So 1 3/4 and 1 3/4, they'd be 2 6/4. But I don't want 2 6/4, I want 3 1/2. Or if I want to leave it in fourths, that's probably better, right? So I'd have 3 and 3, 3 and 2/4. And when I add 1 and 3/4 again, so let's do this on the side. 1 and 3/4. Okay. So if I add that again, I get 4 and 5/4, which is really 5 and 1/4. So 5 and 1/4. I'm going to keep scaling up. 5 and 1/4. I add another 1 and 3/4. I get 6 and 4/4, which is really 7. Scale up again. 7 and 1 and 3/4. I get 8 and 3/4. Scale up again. 8 and 3/4 plus 1 and 3/4. So I get 9 and 6/4, which is really 10 and 2/4, which is really 10 and a half. So I get 10 and 2/4 here. My final answer I want to write is 10 and a half cups of flour. Okay, don't be afraid of fractions. You can do it. All right, this one, the wording on this one I think is confusing. A chef makes gift boxes using different ratios of cake slices. One box has 5 carrot cake slices and 3 chocolate cake slices. Another box has 4 red velvet cake slices and 1 carrot cake slice. Complete each ratio table. So here's carrot cake. So these are both 2 boxes, right? This is box 1. This is box 2. So we're going to scale these up. So multiples of 10. Multiples of 3. 3, 6, 9, 12, 15. Same here. 4, 8, 12, 16, 20. And then multiples of 1, 2, 3, 4, 5. All right, so if we scale those up, we'll be okay. Now, there's going to be questions on this, so we'll come back to this page. If both gift boxes have 10 carrot cake slices, which box has more cake slices? So 10 carrot cake. Let's look for that in our ratio tables. I've got 10 here. This one I don't go up to 10. So you could keep scaling up, or my suggestion is let's make 10 over here and think about the original 1 to 10 would be times 10. So 4, if I multiply by 10, I get 40. So I get 40 red velvet slices. So which has more cake slices? Well, this one has 50. This one has 16. So it's got to be box 2, red velvet and carrot cake. So it's this one. All right, and this one about Nigel. He burns 50 calories per 25 minutes of training. Complete the table. And when we do this, 50 calories, 25 minutes. So I got to find, what do I have here? I have minutes. I have 25. 50 has to go here. So if I scale up to 50 minutes, that's a times 2. This table gets a little tricky because it's not in order. Now I scale down to 5. So I could think 50 divided by 10 gives me 5. Divide by 10, I get 10. Got to scale down to 1. Divide by 5. Right? Divide by 5. So I get 2. Now I got to go up to 75. Now, you could be clever and go back here and think counting by 25s. 25, 50, 75, 50, 100, 150. And then I can continue this here. 75 to 100. Continue this scale. We added 50 each time, so I could go up to 200 here. When we plot these, we're going to plot these the best we can. So 25 minutes. I got minutes here on my x-axis. Calories on my y. So I got to go to 25. And then 50 would be between 40 and 60. So I'm going to put that here best I can. 50, 100. I'm going to go over to 50 and up to 100. Now, if you want to, you can go ahead and write the ordered pair there if that helps. That might be a good check as you're doing this too. 5, 10. So 5, 10. 1, 2. Now 1, 2 is over here. So I'm going to say do your absolute best when you write this one because that is really tricky. right? It shouldn't be over here, but it should be just about there. Now I got 75, 150, so 75. And then 150 would be about here, it looks like. Yeah. Make sure I make that dot pretty prominent there. So I have 75, comma, 150, and 100, 200. Now, because these are in proportion, let's check this out. So 200. So here's a little tip here, again, 100, 200. We talked about this in class a lot. Since this ratio table is in proportion, I multiply by the same thing, divide by the same thing. When I plot this, I can kind of put my pencil like this, and it should be pretty much a good straight line, right? It might be a little different here because we had to do our best plotting with those lower ones, but it should be pretty straight. If you notice your points are going this way or they're going like this or something, then we got something wrong, but pretty much a straight line here. And if we had a computer program to plot it, it would be exactly straight. All right, we're going to refer back to this too. How many calories will Nigel burn if he trains for 1 hour? Remember that this means 60 minutes. So let's use what we have from the table here. I'm going to typically use this where I have 1 because 1's easy to work with. So I have 1 minute. Remember, the words matter. 1 minute, 2 calories. If he trains for 60 minutes, how many calories? Scale up. Times 60 times 60. So I have 120 calories burned. How many minutes would he have to train to burn 150 calories? So now we're going to go to 1 minute over 2 calories. We want to scale up to 150 calories. So if I do this, it's times 75 times 75. So this becomes 75 minutes. Now, you could have also gotten that from your chart here. We have 150 calories right here. Okay, so the answer is 75. How many calories would he burn in 50 minutes? We have that in our chart, actually. We have 50 minutes right here. Okay, for the purpose of this video, let's do our ratio, though. So 1 minute, 2 calories. We're going to scale up to 50 minutes. Times 50 times 50. 2 times 50, we get 100 calories burned. All right, so remember, I hope this helps, and remember to go through each part of that as you need to, rewind, redo, review, all the good things that you do. All right, you're going to be all right. Take care.